Welcome to the deep dive. You're diving into some serious MySQL replication today.
Oh, yeah,
Looks like you're ready to go from casual database user to Replication Pro.
absolutely.
We're going to break down what it is, the different ways to use it, and why it really matters in the real world.
Right.
Think of this as your cheat sheet to understanding data redundancy and high availability in the world of MySQL.
Okay.
Are you ready to dive in?
Absolutely. MySQL replication is a fascinating topic. It's become a cornerstone of modern database architectures. Let's unpack why it's so crucial for performance, reliability, and scalability.
Okay, so let's get into it.
Yeah.
From what I'm seeing in your notes,
Yeah.
MySQL replication basically creates live copies of your databases,
Uh,
mirroring them across multiple servers.
yeah.
It's like having an instantly updated backup of your most important files,
Okay.
but for like your entire database.
That's a great analogy. But it's not just a static backup. It's about capturing every single change that happens on your main server. Every new entry, every edit, every deletion, even changes to the structure of your tables.
Wow.
MySQL meticulously records all these actions in a special file known as the binary log.
So this binary log is like a detailed timeline of everything that happens in the database.
Precisely. And the way it works is fascinating. Each change is documented as an event with a timestamp and a specific position marker.
Okay.
This information is then continuously sent to other servers, which we call replica servers. These replicas use the binary log as a set of instructions to stay perfectly in sync with the main server, mirroring all the changes on their own copy of the database.
So it's like a perfectly synchronized dance routine, but for your data?
Yeah.
But from your notes, it seems like there's more than one way to do this replication dance.
Yeah.
You mentioned standard binary log-based replication and something called GTID-based replication. What's the difference?
That's a great question. Choosing the right replication method depends on your needs and how much automation you're looking for. The standard binary log-based replication is the traditional approach. As you said, it's all about precise steps and following instructions.
Right.
The replica server carefully follows the main server's binary log, tracking its position meticulously to ensure it doesn't miss a single beat.
Okay. It sounds reliable,
Yeah.
but maybe a bit like manually copying down a recipe step by step.
Yeah.
Is there a more streamlined approach?
You're right, it can be quite hands-on, especially if things go wrong. Let's say the main server has a hiccup. Recovering and figuring out where the replica left off in that massive binary log can get complicated.
Yeah.
You might have to manually intervene and tell the replica where to resume, which
Mm.
isn't ideal.
Right. So where does GTID-based replication come in? Is that where the automation kicks in?
Exactly. GTID-based replication, which came onto the scene with MySQL 5.6.5, is like having a GPS system for your database changes. The magic here is that every single transaction, every change made to the database, gets a unique global transaction identifier, or GTID. Think of it as giving each change its own unique fingerprint.
So no more manual position tracking with GTID.
You got it. With GTIDs, replica servers can automatically figure out where they left off, even after an unexpected interruption. They know exactly which transactions have been applied and which haven't, making the whole process much smoother and more reliable.
Okay.
And the benefits go beyond just failover scenarios. GTIDs also bring automated failover, self-positioning of replicas, simplified replica promotion, better consistency checks, and much easier troubleshooting and monitoring.
Wow, that's a lot of benefits packed into those GTIDs. Sounds like a significant upgrade from the manual approach. But what specifically makes all these automation features possible within GTID-based replication? Are there any key features that make it stand out?
Absolutely. GTID-based replication includes a whole suite of features designed to make your life easier. For example, it gracefully handles failed transactions, ensuring that a partially completed transaction doesn't wreak havoc.
Yeah.
It also prevents duplicate transactions, making sure a change isn't accidentally applied twice. It supports various complex replication setups and drastically improves crash-safe replication. In essence, GTIDs give you a much higher level of confidence that your data is safe, consistent, and in sync.
That's fantastic. It sounds like GTID-based replication has really simplified things. But now I'm wondering, with all these different ways to replicate data, how do you choose the best approach? Is it a one-size-fits-all scenario, or are there different strategies depending on what you're trying to achieve?
It definitely depends on your specific needs
Yep.
and what you want to accomplish with replication.
Okay.
It's about choosing the best team formation to meet your goals. We usually see three common architectures. The first is called primary replica,
Sure.
sometimes referred to as master-slave. This is a classic setup with one primary server handling all the writes and multiple replica servers following along, applying those changes to their own copies.
So it's like a well-coordinated team with one leader making the decisions and the others ensuring those decisions are carried out flawlessly.
Exactly. Think of a busy kitchen. The primary server is the head chef, taking all the orders and making sure everything runs smoothly,
Yeah.
while the replicas are like sous chefs, diligently following the instructions and replicating those dishes to perfection.
Yeah.
This structure is perfect for distributing read operations, taking the pressure off the main server.
Okay. So it's about teamwork and efficiency. But what if you need more than one head chef? You mentioned something called primary replications, that where we bring in another leader.
You're spot on. Primary, also known as master, is where things get really interesting. In this setup, you have two servers that act as both primary and replica to each other.
Okay.
This means both servers can accept write operations, which is incredibly powerful for redundancy and flexibility.
Whoa. That sounds incredibly powerful, but potentially chaotic. How do you prevent conflicts when both servers are making changes? Wouldn't that lead to a recipe disaster?
You've hit on a crucial point. The setup requires robust conflict resolution mechanisms to ensure data consistency across both servers. It's definitely more complex to manage and troubleshoot compared to the primary replica model, but it offers incredible flexibility and redundancy. Typically, you would need additional middleware to manage write distribution and conflict resolution effectively.
So it's a more advanced technique for those who need the highest level of availability and performance and are willing to tackle the added complexity.
Right.
And I see from your notes that there's even a third architecture, multi-source replication. What's that all about?
That's right. Multi-source replication,
Right.
which became available in MySQL 5.7, is all about bringing information together from different sources.
Okay.
Imagine you have a central hub that needs to collect data from different departments or applications. This architecture lets one replica server receive data from multiple primary servers simultaneously.
So it's like having a central database that pulls in information from various sources to get a complete picture.
Exactly.
That sounds incredibly useful for things like data warehousing and reporting,
Yeah.
where you need to combine information from different systems.
Absolutely.
But we've talked a lot about the how of replication. Let's shift gears and talk about the why.
Okay.
Why should someone go through the effort of setting up MySQL replication in the first place?
Yeah.
What are the real-world benefits that make it all worthwhile?
That's the key question. Why bother with all this replication business? Well, the benefits are pretty significant. Right off the bat, you get high availability. Replication makes sure your data is always accessible,
Okay.
even if one of your servers decides to take an unscheduled break.
So it's like having an insurance policy for your data. No matter
Right.
what happens, you have a backup plan in place.
Exactly. You have an up-to-date copy of your data ready to go on those replica servers,
Oh.
ready to step in if the primary server goes down. This means less downtime during planned maintenance or those unexpected server hiccups,
Right.
just keeping your applications up and running smoothly. And there are different approaches to achieving high availability with replication, each with its own trade-offs.
Okay.
You could have a simple active-passive setup with one primary server and multiple standby replicas. Or you could implement semi-synchronous replication, which makes sure at least one replica has received the changes before the primary server commits them, adding an extra layer of safety. And then there's group replication, which offers even more advanced high availability features, allowing for automatic primary election and multi-primary configurations.
It sounds like there's a solution for every level of risk tolerance
Yeah.
and performance need. You can choose the approach that best fits your specific situation, but high availability is just one piece of the puzzle, right?
Right.
Remember you mentioning scalability as a key benefit. How does replication help with that?
Scalability is crucial, especially in today's world where applications need to handle more users and data than ever before.
Yeah.
Replication is a fantastic way to scale your database horizontally, especially for those applications that are heavy on read operations.
Okay.
By spreading those read queries across multiple replica servers, you can handle a much larger volume of traffic without putting too much stress on the primary server. Think of it like adding more lanes to a highway to prevent traffic jams during rush hour.
It's all about keeping things moving smoothly.
Exactly.
So you're essentially distributing the workload and preventing bottlenecks.
Uh-huh.
And looking through your notes, I see that replication also plays a vital role in data redundancy
Yeah.
and fault tolerance. What's the connection there?
Absolutely. Having those multiple copies of your data across different physical servers provides a safety net against a whole range of potential problems. Think hardware failures,
Hmm.
data corruption, even those dreaded natural disasters that can take down entire data centers. It's like having a backup generator. That kicks in when the power goes out, ensuring your data remains safe and sound.
Okay, so it's all about peace of mind and ensuring business continuity. But how does replication fit into the bigger picture of load balancing?
Replication is a key ingredient in effective load balancing strategies. By distributing those read queries across your replica servers, you're ensuring that no single server gets overwhelmed. It's like having a team of movers efficiently carrying a heavy load. By spreading the weight, they can move faster, more efficiently.
So it's not just about keeping the data safe, it's also about making sure the system can handle the demand and perform at its best. And finally, you mentioned using replication for backups. Can you elaborate on that?
This is one of the less obvious, but incredibly useful benefits of replication. Think about it. By using a replica server for your backup operations, you can create consistent backups
Right.
without affecting the performance of the primary server. It's like having a dedicated photographer who can capture all the action without getting in the way of the main event. This lets you keep your business operations humming along during the backup process and ensures you have reliable copies of your data should you ever need to restore them.
That's a brilliant strategy. It sounds like replication really is a multitasker, addressing several critical needs at once. But before we move on, I think it would be helpful to clarify some of the key terms we've been using. We've been throwing around terms like binary log, relay log, IO thread, and GTID, and I'm not sure everyone is familiar with their meaning.
You're absolutely right. Understanding the terminology is key to navigating the world of MySQL replication. Let's start with the replication master, which is also often called the primary. This is the main server, the one calling the shots. It handles all the write operations and generates those binary log events we discussed earlier. It's the source of truth for your data changes.
So it's the boss, the one making all the important decisions.
Precisely. And then we have the slave, also known as the replica. This is the server that receives and applies the changes from the primary server. It plays a crucial role in maintaining that all-important data redundancy and high availability.
So it's like the diligent assistant, always making sure everything is in order and up to date. Now, what about this binary log we've been talking about?
The binary log, or binlog as it's often called, is at the heart of replication. It's a sequential log file that records every single database change, sort of like a detailed journal that keeps track of everything that happens.
Okay, so it's the official record of all the actions.
Hmm.
And what about the relay log? How does that fit in?
The relay log is a temporary log file that lives on the replica server. It acts as a holding area, storing the changes received from the primary server before they are applied to the replica's database. Think of it as a staging area where changes are carefully reviewed before they become permanent.
Ah, so it's like a quality control checkpoint. And you mentioned two important processes earlier, the IO thread and the SQL thread. Can you remind us what those do again?
Of course, the IO thread is the busy bee on the replica server, constantly fetching those binary log events from the primary server and diligently writing them to the relay log.
Okay,
It's always on the lookout for updates, making sure nothing gets missed.
that sounds like a very important job. And what about the SQL thread? What role does it play in this whole process?
The SQL thread is equally crucial. It's the one that reads those changes from the relay log and actually applies them to the replica's database, ensuring that the replica stays perfectly synchronized with the primary server.
So they work together like a well-coordinated
Yeah.
team, making sure the data stays consistent across all the servers.
Huh.
What about replication filters? I see that term in your notes as well. What are they all about?
Replication filters give you really granular control over what gets replicated.
Okay.
You can use them to filter content at the database level, the table level, or even using wildcard patterns.
Yeah.
This means you have the flexibility to replicate only specific databases or tables
it.
or exclude sensitive information from being replicated altogether. It's all about tailoring the replication process to fit your specific needs and security requirements.
It's like having a customized mirror that only reflects the parts of the database you want to see.
Exactly.
And then there's GTID, which we touched on earlier. Those global transaction identifiers seem to play a key role in making replication more robust and reliable.
They absolutely do.
Yeah.
GTIDs provide that unique fingerprint for every transaction, making it much easier to keep track of what's been replicated and what hasn't.
Okay.
They take the guesswork out of manual position tracking, simplify those tricky failover procedures, and enhance consistency checking. GTIDs are a real game changer for making replication more reliable and easier to manage.
It sounds like they've taken a lot of the headaches out of replication.
Yeah.
But with all these components and features, there must be quite a few ways to configure replication to achieve different levels of synchronization. You briefly mentioned asynchronous and
Yeah.
semi-synchronous replication earlier. Can you walk us through the trade-offs involved in choosing between those?
You're right. Choosing the right synchronization method is a crucial decision. It's all about finding the sweet spot between performance and data durability. Asynchronous replication is the default method in MySQL.
Oh,
It's the fastest option because the primary server doesn't wait for confirmation from the replicas
yeah.
before committing changes. But this speed comes with a slight risk. There's a chance of data loss if the primary server fails, before those changes have been fully replicated to the replicas.
So it's a trade-off between speed and the risk of potentially losing some data.
Exactly. Semi-synchronous replication tries to find that balance between speed and safety. It introduces a small delay, ensuring that at least one replica server has acknowledged the changes before the primary server commits them. This significantly reduces the risk of data loss, but it does come with a minor performance overhead.
So it's a bit slower,
Mm.
but much more reliable.
Right.
And I see from your notes that there's a third option, group replication. That sounds even more robust,
Yeah.
but perhaps more complex as well.
Group replication is a relatively new feature in MySQL, and it really is a game changer for high availability and data consistency. It allows you to create a cluster of servers that act as a single, highly available database system with automatic failover, multi-primary capabilities, and built-in conflict detection and resolution. It's like having a team of expert synchronized swimmers, all working together seamlessly to keep your data safe and in sync.
That's an impressive image. It sounds
Okay.
incredibly powerful, but I imagine it's also more challenging to set up and manage compared to the other methods.
That's true. Group replication requires careful planning and configuration, and it's not the right fit for every scenario. But for applications that demand the absolute highest levels of availability, data consistency,
Mhm.
and fault tolerance, it's an invaluable tool.
Well, there you have it. We've covered a lot of ground today, from the fundamentals of MySQL replication to the different types, architectures, benefits, and key terminology. We even explored those crucial synchronization methods and the trade-offs involved. You're now equipped with the knowledge to understand the power and flexibility of MySQL replication and make informed decisions about how to best leverage it for your specific needs.
Remember, replication is an essential tool for creating robust, scalable, and highly available database systems. It's an investment well worth making, and the insights you've gained today will undoubtedly serve you well as you navigate the world of MySQL and database management.
And remember, if you ever find yourself lost in the replication maze, you can always count on the deep dive to guide you through. Until next time.